Hello and welcome back to another video. In this problem we're asked to prove that the equation has at least one real root. We have the equation 100e to the negative x over 100 is equal to 0.01 x squared. So what we want to do is we want to subtract 0.01 x squared from both sides. What this does is these cancel and we have 0. And on the other side we have 100e to the negative x over 100 minus 0.01 x squared. We're going to call this f of x. And we're looking to prove that there's a value of x such that f of x is equal to 0. And we're going to do this using the intermediate value theorem. So with f of x, we have this term and this term. This term is an exponential function, and this term is a polynomial. And we know from theorem 7 that both of these types of functions are continuous over their domains, which for these equations in particular is all real numbers. And from theorem 4, we know that subtracting those two, the difference will be also continuous over the same range as its parts, which is all real numbers. So by the intermediate value theorem, we know f of x is continuous over all real numbers. And what we can say is, if we take f of 0, that's 100e to the negative 0 over 100 minus 0.01 times 0 squared. That's equal to 100. And f of 100 is equal to 100e to the negative 100 over 100 minus 0.01 times 100 squared. That is equal to negative 63.2, approximately. So by the intermediate value theorem, since f is continuous, and f of 0 is greater than 0, and f of 100 is less than 0, there exists some value of x that when you plug it in to f of x, it equals 0. Why? Well, if we know it's a continuous function, and at 0 we have a positive value, and at 100 we have a negative value, there's no way to get from here to here without making a jump unless you cross the x-axis, right? And if it's continuous, then there is no jump, so it has to cross the x-axis at some point, and therefore the function has a root. Has a root. In part B, we're asked to use our graphing device to find the root correct to 3 decimal places. So I have the function pulled up here. And all we need to see is where is the root. And this isn't the most interesting process, but if we look at the intersection point, right, Desmos will actually label it for you, 70.3470. So at the value of 70.347, there is a real root. A and B.